Okay, so yesterday, or 3 minutes ago, we calculated the area between two curves that intersected twice, right? If they didn't tell us where they intersected, we had to find the intersection, they intersected twice, right? So sometimes they gave it to us, and sometimes we had to find it. And how did we find it? Setting them equal to each other. Why are you laughing? Is it weird that we're recording?
Yes, it is.
Okay, so sometimes they gave it to us, and sometimes we had to find it by setting them equal to each other and solving the system of equations. Today, we're going to find the area in between two curves that intersect more than twice. So what happens if they intersect more than twice? We need to find all of those different areas. Okay? We're going to follow 3 steps. The first one is you need to find all of the intersections. Where do they intersect the first time? Where do they intersect the second time? Where do they intersect the third time? And so on. So that I can figure out what intervals I have. Okay? My second step is I want to see which function is above the other one in each interval. Maybe in the first interval, f is greater than g, but in the second interval, g is greater than f. So I've got to figure out who is greater in each interval. Okay? My third step is I want to set up an appropriate integral and evaluate. So maybe if they intersect 3 different places, right? You have 3 different areas, I need to do 3 different integrals. Maybe from 1 to 3. Then from 3 to 5 is going to be something different. And then from 5 to 7 is going to be a different integral. Okay, so I have to set up the appropriate integral and evaluate each of those. You ready? Huh? Do you think I'm not talking loud enough, Zach Brahman? Zach Brahman.
Yes, Miss Kelly.
Do you think I'm talking loud enough?
Now.
Oh, okay. So, example number 1 says that I need to find the area. My voice is kind of hurt. The area in between these two functions. F of x is 3x cubed minus. Uh-oh. No. That's supposed to be a square. Does it say a squared on yours? Make it a square, please. That's what happens when I do that. This is what happens when I do it at midnight.
You shouldn't procrastinate this.
Give me back my packet. Give me back my packet right now.
We're recording. Might want to come with one to make it squares.
Make that one that I made a squared, Zach Rotman says. All right, 3x cubed minus x squared minus 10x, and the function g, which is negative x squared, plus 2x. That's right. All right. If they didn't give us a graph, where do we need to start? Finding my intersections, right? So how would I find my intersections if I needed to find my intersections? Set them equal. Will you set them equal to each other? They're not always going to give you a graph. So let's set them equal to each other so I can figure out where they intersect. Okay? Can I move everything to the same side? That's going to make my x squareds cancel, right? If I move this 2x over, my x squared over, I'm going to get 3x cubed minus 12x equals 0. How do I factor from there? Okay. Let's do a 3 and an x. Let's do a GCF. 3 and an x. If I take out a 3 and an x, then what's left over? X squared minus 4. Bless you. Bless you, Zach Freeman. Oh. Oh, bless you, Ryan. Okay. I could factor again, or I can set it equal to 0 already. Let's factor it again. Can this factor in a negative 2 and positive 2? Or when I set it equal to 0, I would add 4 to both sides, and I would square root, and I would still get 2 answers, right? Anytime I square root, I add plus or minus. I get 3 answers. I get x equals 0. I get x equals positive 2, and I get x equals negative 2. What does this mean? That's where they intersect. So they intersect 3 different times, right? They're going to intersect at negative 2. They're going to intersect at 0, and they're going to intersect at positive 2. So we have to set up how many different intervals? 2. Right? One in between -2 and 0, and one in between 0 and 2. But in those intervals, either way, we've got to do what? Figure out which one's greater then. Is F greater or is G greater? So how am I going to figure out who is greater, which function to put first in my integral between -2 and 0? Without a graph, because they're not always going to give us a graph. Zach Brotman, yes, he has his hand raised. What's your question, Zach?
I like the top of
You could do that. That's a lot of work. Let's do something way easier. Plug in. Plug in what number? A number in between those two. So let's do -1. Right? I wouldn't want to, Jessica Thomas, do 0. Why?
they're equal.
Right. And if I plug in a 0, what would happen in F and G? They would equal each other. Right? And so that's kind of your question. That was her question that she asked earlier about them being equal. Yeah. Okay. So if I plug in a -1, so if I do F of -1 and G of -1, who's greater? Who? F? Okay. So in this interval, F is greater. So then how do I figure out who's greater between 0 and 2? Let's plug in 1. Kristen Snyder, very good. If I plug in a +1, who's greater? G? Zach Cleveland?
Yes.
Okay, G. Are you ready? We found our intersections. We found who's greater. Our third step is to Vincent, G. Coppola something. I don't know your last name. It's too weird. What do I do? I know. You're too messed up with me. I forgot it too. Oh yeah. We found our intersections. We found who's higher, who's greater in each interval. What's my third step?
Set up
Okay, let's set up 2 different intervals. My first interval is going to be from where to where? -2 to 0. Who's bigger? F, which was, I already forgot, 3x cubed minus x squared minus 10x. Minus G, which was -x squared plus 2x. dx, and I'm running out of room. Oops. I have another integral, don't I? From where to where? 0 to 2. But in that interval, who's greater? G. So now I got to do it the other way. I got to do -x squared plus 2x minus 3x cubed minus x squared minus 10x dx. This is going to give me, my first integral is going to give me the area in that interval. My second integral is going to give me the area in that interval. Then how do I find the total area? Add them together. Are you okay with that? Can we skip this integration? You can do it on your own. You can figure out what the area is of that first interval, and I think you get 12. You can find the area of the second interval, and you get 12. So what is the total area in between these two curves?
0.
Zach Brotman, it is not 0. It is 24. Make sure you do it, practice it, make sure you get the integration right, but you should get 24. Good?
Yes,
All right.
Miss Stephanie.
Thank you, Zach Brotman, for the confirmation. Here we go. What happens, though, if our graphs are sideways? Well, what do I mean by sideways? Well, all the graphs that we've done have a nice little parabola and another little line that's above it, and we've been looking at it vertically, right? We've been doing greater than, meaning above and below, top, bottom. What happens if my parabola is kind of sideways, right? What happens if it's sideways? You still could integrate it with vertical rectangles. Another way of saying that is doing the top curve minus the bottom curve, or the greater function minus the least function with respect to x. So on the x-axis, how far did I go? What were my limits? My top function, f of x, minus my bottom function, g of x, or whatever they were, with respect to x. But could I also do it with horizontal rectangles? Do you do this? Turn your head sideways. Turn your head sideways. No, sideways. The other way. Okay, so do this. So now if I have my head sideways, what am I integrating it? What are my limits of integration? They're y's now, right? I wish you guys could see this. This is hilarious. Okay, so now I'm doing it on my y's, right? So from here to here are going to be my limits. It's still the intersection points, right? But it's the y values of my intersection points, right? And it, go back. Okay, so now it's still sideways. Which function is greater than now? G of x, G of y, right, whatever it is. So this way, it's still my highest function. If you put your head back up, it's more like the rightmost curve minus the leftmost curve, or you can put your head sideways again and just do it greater than and less than. Either way. But this time, you're not integrating with respect to x anymore. You're integrating with respect to y. So all of your variables inside your functions, inside here and here, should be y's. Okay? So if they give it to you, y equals blah, 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 you need to resolve it so that it says x equals blah, blah, blah. Okay? Now you're doing it sideways. Okay? Here we go. In week 5, why are you laughing?
I'm just imagining all of us doing the AP test.
No, it's gonna be so funny. I love it. Okay, find the area in between x equals 3 minus y squared. So this is the parabola that's going sideways. That's why it looks different. That's why it's solved instead of y equals blah, blah, blah. It's x equals blah, blah, blah. Okay, and x equals y plus 1. So again, this is with respect to y instead of x this time. Okay, so there's still both parabolas and lines, but this time we're going to do it with horizontal rectangles. So I have to find my limits of integration. I've got to figure out where they intersect. How do I figure out where they intersect? Let's set them equal to each other. So I'm going to say 3 minus y squared is equal to y plus 1. It's a factor problem. Move everything to the same side, and I get y squared plus y minus 2, right? The microphone isn't on. I'm going to be so mad. I'm going to factor. I forgot to check that before I started classes.
Smart work. Like, do we right?
Yeah, I think so. I don't know. Positive 2, negative 1. So that means y equals negative 2, and y equals positive 1, right? This is with respect to y, though. Okay? They only intersect twice, which means there's only one region in between those two intersections. And my limits of integration are going to be from negative 1 to 1. But remember, this is with respect to y now. So make sure you do your dy instead of dx. So, I've got to figure out who's bigger. But I want to do it with respect to y, which means I want to figure out which x value is bigger, right? You turn your head sideways, are you looking for which x value is bigger? What values do I want to test in between? In between negative 2 and 1, so you choose 0? Okay, so in between negative 2 and 1, so if you choose 0, who is greater than? The 3 minus y squared is? You okay with that? 3 minus y squared? Without looking at the graph, because they're not always going to give you one. The 3 minus y squared should be greater than. If you plug in numbers, you should get a bigger x value than the other one. minus, what was the other function? Y plus 1. Again, make sure your variables match. Make sure that they're y's because you're doing it with respect to y. You could distribute the negative through, correct? And you can integrate each little part, correct? So I'm not going to take time to do that. I would like you to do it. I just don't want to take time to do it right now. So why don't you do that on your own? When you evaluate, you should end up getting 9 over 2. Did you get 27 over 6 again? Which reduces to 9 over 2. Okay? Try it. If you didn't get it, be careful with your common denominators. Okay? Well, kinda.
Since it's tomorrow, we need to check our test.
We got Joe Ernst. Quit asking me about your test. I know you're Joe. You're not Tom. Quit asking about your test, Joe Ernst. Okay. We have some calculator stuff. Should I? Yeah, could you read the calculator steps? You plug f of x into your y1. You plug g of x into your y2, but I make it a thicker line so I can tell the difference when I go to graph it. I'm going to push graph so I can see the picture. I'm going to adjust my window so that I can see my picture. I'm going to then find my intersections by doing second trace, which is your calc, and going to intersect. It's going to say first curve. You're going to push enter. It's going to say second curve. You're going to push enter. It's going to say guess. You're going to push enter. So you can figure out the intervals. You're going to set up your integral into your y1, your y3, and your y4. So if you need to do this, y1 minus y2, and then a y2 minus y1, right? So you have f minus g and then g minus f. And then to integrate it, you're going to do second calc number 7. But make sure you're only turning on the one you want to integrate. If you have all 4 of them turned on, it's going to do the first one, which is not going to be correct. Okay? Try that and see how that goes. So your homework for tomorrow are your 7-1A, and then I'll hand you your your 7-1B should be in your lovely packet. But there's no shading, so find your shading yourself. Okay? Email me if you have questions, and then we'll work together on Monday, okay? Behave yourself tomorrow. I'm sorry you're not going to be able to see my wonderful outfit. Really, Bella? Goodbye.
Really?
Yes, Zach Brotman.